The Dexter Manipulation Project at NYU's Robotics Research Laboratory. The experimental setup includes Utah MIT Dexter and 416-degree robot hand at 2.5D. The joint hand activates hands pass through a flexible motor connected to mastins. Sensor hand by joint and tendon measurements in real time, and digital analog control loops permit various control schemes to be implemented. In addition, we have a custom VPL Data Glove, a flexible glove with optical sensors which can measure the shape of the wearer's hand. It provides 12 angle measurements covering 3 fingers and the thumb in real time, which is sufficient to measure all joint angles except the most distal ones. Our custom glove configuration differs from the standard one in being able to measure the angle between the thumb and the normal to the palm. A Polhemus sensor on the glove also measures the position and orientation of the glove in space. The glove angle measurements are used to control the Utah MIT hand, and the Polhemus position and orientation measurements are used to control the Puma. Our control architecture has 3 software components: Condor, a low-level real-time monitor which directly controls the hand; HIC, a hierarchical control system running on top of Condor; and Sage, a real-time supervisory control system which interfaces between the Puma, Dataglove, and HIC. Condor and HIC run on 4 68020 boards and a Sun workstation. Sage runs on another 68020 board, and Sage and HIC communicate over an Ethernet. In this video, we will demonstrate using the data from the Dataglove to teleoperate the Utah MIT hand in real time. We begin with some simple gestures which show that the hand can assume various grasping configurations accurately. Note that the Puma follows the position and orientation of the glove, and that when the glove fingers touch, so do the MIT hand fingertips. The system does real-time inverse kinematics for both the Puma and Utah MIT hand remotizer to make sure no collisions occur between the hand and Puma, or hand and table, and that motions remain within the workspace of the Puma and remotizer. In this experiment, we use the hand to stack blocks. In this experiment, we replace the receiver of a telephone, pick it up again and put it on the table, and dial 911. In this experiment, we reopen a milk carton, pick it up, pour milk into a cup, and put the carton back on the table. In this experiment, we pick up a cup of milk by the handle, pour it into another empty cup, and put the first cup back on the table. In this experiment, we pick up a nut and screw it onto a bolt. Both the nut and bolt are standard unmodified industrial parts. These experiments demonstrate that the VPL Data Glove and MIT Hand are user-friendly devices.